What's up, YouTube? Back with another video as promised, this time on cutting and engraving aluminum. This is something that I struggled with for a bit on my last project and kind of wanted to dive a little bit deeper on some of the settings and bits to use and kind of share that info with you guys to kind of help you get going. Again, I'm not a professional, I'm just a hobbyist who's been a fabricator for a long time. And yeah, wanted to cover a few things in this video. First thing is bits, and then I'll show you some of the finishes on these sample pieces here, and then we'll go over some of the accuracy, and then chips, and then at the end I'll show some videos of the various bits and processes so you can kind of hear the machine, and I'll kind of go over RPMs of the router and whatnot. So here we go. So these are the bits I used for these test pieces here. For starters, we'll go over the engraving bit, which is a 60-degree V bit that I got from Genmitsu. This was just bought off of Amazon, and that's what I used to engrave the three pieces you see here. I ran the operation twice because the first time I ran it, I saw some burrs and whatnot, so running it a second time really helped clean it up. And you can see the result here is pretty good. There's no cleanup on this. I think if you maybe hit it with some Scotch-Brite, it'll look a lot better. But as you can see, no major burrs, and it's pretty clear. So that was the engraving. For the cutting, I have a 1/4-inch single flute end mill here, purchased off of Amazon. This is an upcut bit, and it is made by Aquilin. Tooling life better. For this piece here, I used a 2-flute end mill, and that's from OSG Tap and Die. That's that guy there. And then for this last piece, I used the standard Genmitsu flat nose single flute end mill, and that is also from Amazon. So now I want to show you some of the finishes that I got using the various end mills. This is using 25 inches per minute feed rate, and this is a 0.5 millimeter depth of cut. You could definitely push these guys to cut a little bit deeper, but I wanted to just give you some settings that are good to start with, and if you want to push a little farther, then you can go from there. So test piece consists of a hole, a slot, and then a profile cut. So showing you the hole there, pretty good surface finish. Same thing with the slot. Let's see if we can pick it up here. And then the profile. So that's for the 1/4-inch O flute. This is the 1/8-inch 2 flute. Again, the hole, slot, profile. And this is the 1/8-inch O flute. Not the best finish here, as you can see. But there's probably some more tweaking I can do with this guy. And if you want to see all three of them, again, you have the 1/4-inch up top. In the center, you have the single flute 1/8-inch. And then on the bottom, you have the 2 flute 1/8-inch. So now we'll go over accuracy. This is an 8 millimeter hole, and the slot should be 8 millimeter by 25 millimeter. So as you can see, pretty close to 8 millimeter there. 8 on the nose. Not bad for a hobby machine. And then for the slot, sorry, it keeps turning on me. Yeah, pretty close. And then same deal for the length. Pretty close. That's the 1/4-inch O flute. Now we'll do the 1/8-inch O flute. little smaller on that one. And there is some kind of like galling in there, which could be contributing to the hole being smaller. Length looks slightly over, and there was a bit of a deeper cut there. I'm not too sure what happened. I wasn't looking at it when it finished. And then same for the width, slightly under. Oh, there we go. Again, there's some galling in there, so that's gonna put the measurements all over the board. This is a 2 flute, much nicer surface finish, so let's see what we got here. Yeah, 8 on the nose. And then yeah, width is a little bit under. And same for the length. So for the settings, I chose, there's different lead-ins in the software that I use. So I used the smooth feature for the holes, and then I used a zigzag ramping feature for both the slot and the profile cut. And just kind of overall, I think the best surface finish by far is the 2 flute in the 1/8 inch bit category. And honestly, this single flute gave a really nice surface finish, as you can see. And I do want to note that I did try a 0.7 millimeter depth of cut, and it gave a really nice and smooth finish. The issue I had was retaining the part onto the spoil board. I was using the blue tape and super glue method, and you could see here it came loose on the hole and it kind of dug in there. Same thing on the profile. It was just moving around on me, and I just couldn't hold it down with just the tape at a 0.7 millimeter degree of depth of cut. So, and then this is an actual part that I made. A cousin of mine passed away recently, so I made a few of these for the family. And I was using those same settings, which is 25 inches per minute feed rate. The depth of cut was 0.5 millimeters. And I used the 1/4 inch single flute bit for this here. So the last thing I want to show you guys before we cut to some of the machining is the chips. So chip load is really important when machining anything. And I just kind of wanted to give you just a visual of the different chips that I got from the different bits that I used. When I was really struggling on my last project, I was getting dust, and that's not what you want. Basically, I was cutting too slow, and the bit was just rubbing, and you know, the material that was coming off the part was actual dust. And what you want to see is chips. This is from the 1/4 inch bit, and you can see you got some nice big chips there. And you want chips because that actually pulls heat from the part and dissipates you know, the heat, so you're not burning up your bit. So that's the 1/4 inch O flute. This is the 2 flute, so these are a little smaller. And then lastly, the single flute. So again, can't stress that enough. You want chips. There's some really good chip load calculators online, which I use to kind of get a baseline, kind of get in the neighborhood of where I wanted to be cutting. So definitely recommend you guys look into those. The last thing I quickly want to cover is RPMs of each bit, because if you look at the clips, it can be confusing because there's so many. But this is at 25 inches per minute, 0.5 millimeter depth of cut. And the 1/4 inch O flute, I was running at 15,000 RPM. The 1/8 inch 2 flute is at 18,000 RPM. 1/8 inch O flute was 12,000. and all the engraving was done at 10,000, which is setting number 1 on the router. All right, we're ready to engrave here. We got the 60-degree V bit installed. We're gonna run the router on setting 1, which is about 10,000 RPMs, and we will not be using air assist. Here we go. Alright, we're here ready to cut the next test piece. I already did the engraving, which was the same settings as before, same bit, same speed. Now we're going to cut with the 2-flute 1/8" end mill. The speed is going to be a little bit faster, so we're going 1 notch past number 3 on the router, which is 18,000 RPMs. Here we go. Ready to move on to the slot. So same deal, speed's the same, air assist just like before. Here we go. Alright, and now we're on to the last op, which is the profile cut. Again, no changes to anything, still using air assist. Here we go. Alright, so we got the 1/8" O-flute bit installed now. We've already done the engraving, same settings on that as before. So again, 1/8" O-flute bit installed. We're at about 12,000 RPMs, which is about number 2, just a little bit before number 2 on the Makita router. So here we go. Now we're ready for the second op, which is the slot. Here we go. We got the slot done. Now we're going to move on to the last op, which is the profile cut. Here we go. Alright, got the 1/4" O-flute bit installed. We have the router set in between 2 and 3, which is about 15,000 RPMs. This time we will be using the air assist. So, gonna fire up the router, hit the air, and hit go. All right, 1/8" 2 and 3 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 1/8" now we're ready to do the slot. It's going to be the same procedure. We're still at the same speed, 15,000 RPM. Going to use the air assist for this procedure as well. Here we go. All right, so now we're ready for the perimeter cut. It's the last op in this test piece. Same speed, air assist, nothing's changed. Here we go.